Welcome! In this video, we're going to learn how to use LangGraph conditional edges without using any AI model or large language model. We'll build a simple workflow that checks whether a number is even or odd. This example demonstrates that LangGraph is not just for AI agents. It can also orchestrate general Python workflows. First, we import the required modules. Typed dict helps us define the structure of our shared state. Next, we import stategraph, along with the special start and end nodes that define where our workflow begins and ends. Next, we define our shared state. The state contains two fields. The number field stores the input number. The result field stores the final output after processing. Every node in the graph can read from and update this shared state. Our first node is called check_number. This node doesn't perform any processing. It simply passes the state to the routing function. In real-world applications, this node could validate input, read data from a database, or call an external API. If the number is even, LangGraph executes the even_node. This node updates the shared state by setting the result to even number. If the number is odd, LangGraph executes the odd_node. This node returns odd number as the result. This is the most important part of the workflow. The routing function contains standard Python logic. If the number is divisible by 2, it returns the label even. Otherwise, it returns odd. Notice that we're not using AI or an LLM here, just simple Python code. Now we create a LangGraph using our shared state definition. Next, we register the three nodes. The graph now knows about the check, even, and odd processing steps. We connect the special start node to the check node. This tells LangGraph where execution begins. This is where LangGraph becomes powerful. After the check node finishes, it calls the route function. If the function returns even, execution moves to the even node. If it returns odd, execution moves to the odd node. This decision is based entirely on Python logic. Both processing paths eventually connect to the end node, completing the workflow. After defining the workflow, we compile it into an executable graph. Let's execute the graph with the number 10. The workflow starts at the check node. The routing function determines that 10 is even. LangGraph executes the even_node, and the final result is returned. Now let's try the number 15. The routing function determines that 15 is odd. LangGraph follows a different execution path and runs the odd_node.